Hello viewers, welcome to my channel KK Concepts of Electrical Engineering.
Single spherical shell of charge. I am considering this sphere radius r1 and I am considering a charge at the surface of the sphere, a positive charge. Total charge is q. Imagine this radius is dr. The total radius is r1 plus dr. Since the medium is air, epsilon r is approximately equals to 1. Epsilon naught equals to 8.854 into 10 to the power of minus 12. D equals to, we know, epsilon naught E, or this is the sphere surface. On the surface we are having the charge Q, positive charge. Now inside the surface there is no charge, that is Q is equals to 0 inside surface, and Q equals to Q positive on the surface. Let us see what happens to E. This is R. When R is 0, that is inside the sphere where there is no charge, the charge is 0, then E equals to, we have a formula, E equals to Q by 4 pi epsilon naught R square, where R is the distance between the charge and the point where we are finding the electric field intensity. So the charge is on the surface and we want to find out electric field intensity at the center of the sphere. This is an imaginary sphere. So where R is equal to 0. Then when R equals to 0, what happens to E? When R equals to 0, E will be infinity. But inside the sphere, the Q is 0. So this is also 0. 0 by 0 is 0 is the value. So as it increases, the R value or the radius value increases, then we have two intersecting points. This is R1 and this is R1 plus dr at R1. And one more point is R1 plus dr. The electric field intensity E is 0 at 0 and inside the surface Q is 0. So electric field intensity always remains 0 until this point. And at R1 we have a charge of Q plus. So Q plus will be there and radius will be there, and here we are going to get some value E based upon this formula, that equals to Q by 4 pi epsilon naught R square. When we going away from the surface, the charge is only Q plus here, and the charge will remain Q plus constant, and this R value is increasing, then E value automatically decreases. So this will decrease. And if you go far away from the charge, then this value is going to reduce. We'll try to find out the value of V. That is voltage potential, that is given by negative integral of minus infinity to R E dr. When you substitute the value of E and integrate this, then you are going to get Q by 4 pi epsilon naught R. This is V. Consider inside the sphere. At the center of the sphere, voltage is 0 since Q is 0, but at the surface of the sphere, voltage is this value. Then the difference between these two values is always the V. When you compare these two formulas, E and V, here R square value is more than R value, or else denominator of the E is more than denominator of V. Then the total value of V is always more than the total value of E, and it will remain constant until R. So inside the sphere, the value of V remains constant up to the point R. At the point of R, V value equals to Q by 4 pi epsilon naught. Then, as the R increases, the denominator increases, the total value decreases. So, this belongs to the curve V, and this belongs to the curve E. Now, what about rho S? Rho S equals to Q by 4 pi R square. As the Q value is 0 inside the sphere, rho S value is 0. Okay. And at R, at this point, the Q value is Q plus, so rho S value will remain here. So this is rho S, surface charge density. Our surface charge density is going to present at the surface where the charge is present. But inside the surface where the charge is not present, the surface charge density will be 0. And when you go away from the sphere, there is no charge. The surface charge density always remains 0.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.